Now serial port. In the last class, under the interface, we have discussed parallel port. Now in this case, we will discuss the serial port. Now this is the processor and this is the interface and these are the IO devices. Now from the processor to interface, the data transfer takes place in parallel fashion. But coming to the in the serial port, now from the interface to the IO devices, the data transfer takes place bit by bit. Now at a time only one bit will be transferred. Now coming to the now let me explain about the parallel processing transfer and serial. Now this is the transmitter and this is the receiver. Now for example, if I take 8 bits, now the data bit is 8 bit, the data bus is 8 bit, then all the 8 bits are transferred at a time, then that is called the parallel transfer. Now coming to the serial, if this is the transmitter and this is the receiver, only one serial line, only one line is connected between transmitter to receiver along with one ground line. Now at a time only one bit will be transferred. Means what? 8 bits are should be transferred. Means what? First bit will go first, next second one, third one, like that. So one after the other. Now here with a single clock, all the bits are transferred. Now for here number of how many number of bits are there? Those many number of clock signals are required. Means what? Speed here in the parallel it is more, speed here it is less. But number of connections between transmitter to receiver is more here, number of connections are less here. And the complexity is more here. And because of these many connections, cost also increases. So here this is a simple and the cost is less. So that's why now whenever the IO devices, which IO devices are nearer to the processor, then there the parallel transfer takes place. And if the processor want to send the data to the far distance, then that time serial transfer takes place. So now here, now if the interface is receiving the data in parallel and the data loaded into this input data register is in parallel. And after that, this data should send to the IO devices in serial manner. Means how this happens means inside one more register is there, that is nothing but a shift register. By using these shift registers, so the data is transferred. Now once the data is loaded means what? One more register is used, that is a shift register. By using these two register, so data is converted into parallel to serial. Now if the data is reading the data from the IO device, now data interface will receive the data in serial, and within the interface it will convert this serial data into the parallel by using the shift registers again, and the processor will read the data from the data out register. Now this is what happens inside the processor. Now that we will try to analyze by using the block diagram. Now coming to now the block diagram for the input device, block diagram for the output device, how the parallel port we have analyzed, the same here also, serial port also. Only the difference is what? In the interface, one more shift register we need to add. That is the difference. Now here we will see the combined, both the input device and output device, both are connected to the same interface and for the serial port. Now here, if the processor want to read the data, now this is the input device, data is coming in serial. Now whatever the data is coming in serial, that will be loaded into the input shift register one by one after the one. Now if I take 8 bit means what? 8 flip-flops are register is nothing but what? Group of flip-flops. Now like this total 8 flip-flops are there. The first bit will come here. For first clock, first bit will come here, and after that for second clock, first bit will come here, second bit will be loaded here. For third clock pulse, this bit will come here, this bit will come here, and this bit will come here. Like that, total bits will be filled into the these registers, this register, shift register. And once after this complete register is filled, then that will be loaded into that in parallel into the data in register. After 8 bits are filled in this 8-bit shift register, then after that what? These 8 bits are loaded into the data in register. Now from this data in register, it is similar to the parallel port only. Now, once the data is available in the data in register, if this state buffer is enabled, how this is enabled, that already we have discussed. So when the data, when address is matched, when the read write signal is given, all the signals are given, then enable signal is, now if this bit is equal to 1, then this will enable the tri-state buffer. Then whenever the tri-state buffer is enabled, then whatever the data is available on the data register is available onto the, is placed onto the data bus. Thereby, the processor will read the data. Now, how the serial data is converted into parallel and how the processor is reading. Now, if the processor want to send the data, then first it will place the data on the data bus and it will give the address and it will give the write instruction. And after that, whatever the data is available, that is loaded into this data out register. Now this data out register, whatever the data is available, that is again placed into the output shift register. Now from this output shift register only, now here, now if these flip-flops are connected together and if the output is taken only from this last flip-flop, then first the data will come, now this flip-flop data will come out. For the next clock, this data will come out here and this data will come out here. For the third one, this will, now the data will shift like this. So thereby what, how many number of, if for example, if I take 8-bit shift register, now 8 clock pulses, the complete data will come out one by one bit by another bit. So like this, the parallel data will be converted into serially by using this shift register. So already the shift register you have studied in the digital electronics. No, for the first clock, now if the data is available here, now like this 1 0. Now if I'll take the 4 bits, 4 flip-flops only, 1 0 1 0. Then for first clock pulse, this one will come out. For the second clock pulse, this one will be loaded here. For first clock pulse, this one will 0 will be come out. 1 will be loaded here, 0 will be loaded here, and 1 will be. For the second, this 1 will come out, and 0 will be loaded here, 1 will be loaded here. And for third clock, this 0 will come out, and 1 will be loaded here. Like that, for every clock, so 111 bit will come out. This is the serial out. Now for this, now here if you see, if we observe the block diagram, here chip and register select is there. Now here to select different registers, like now here if you see status register is there, status and control register is there, data out register is there, data in register is there. Which register should be selected, depending upon that it will give the register select bits. Now here 2 bits are given. So for total 4 combinations are there. Depending upon that, it will select the, so one combination is allotted to the one register, address of one register. So depending upon the combinations, it will select the different register. Now read write. If the processor want to read the data, it will give the read command. If the processor want to write the data, it will give the write command. For reading the input, read command. For reading the status register and control register, it read. And if the processor want to write the data, then it will give the write. If processor want to send the data to the output register, it will give the write command. And also processor want to put the control word into the control register, then also it will give the write command like that. Now coming to the read and accept. So these are almost like a handshaking signals. So whenever the processor is ready to send the data, it will send the ready signal. If the interface or IO devices are ready to accept, then this will send the accept signal. These are nothing but what handshaking means. What both the devices are communicating before going to transmit the data. Now coming to the interrupt. What is interrupt? Already we have studied. Whenever the device is ready to send the, now instead of polling. So in the previous classes we have, in the previous lecture we have seen that microprocessor is reading the status of the interface. That is nothing but a polling. Instead of that, whenever the device is ready to send the data, then device itself give the interrupt signal. So thereby what? Processor will read the data and write. Now, if the processor is sending the interrupt, then what is this status means what? This status gives the whether the registers are filled or not, that also indicates. And also if the data transfer is taking place, if any errors are occurring, that error information also given by the status register. So this is about the serial port for the both input device and output device. And here, if you see two more receiving clock and transmission clock, here we need to see few terminologies. So the speed of the transmission is given in terms of bit rate. Bit rate is nothing but what number of bits transferred per second. Number of bits transferred per second is the bit rate. So now here the bit rate and one more terminology is baud rate. Number of signals per second is the baud rate. Now for whatever the devices we are using, serial in and input device and output devices, whichever the device we are using, for each and every device there is a specific speed. So accordingly, the clock should be selected in the interface. That's why if the receive for the receiving devices for receiving clock, for the transmitting devices transmitting clock. So baud rate should be selected. Now here also for sending the data, for several standards serial interface have been developed. One is a UART, one is a UART, and another one is a RS-232 cable. RS-232C. Now this is about the serial interfacing circuit.